Dear guests, welcome again. We just start recording the webinar for someone who wouldn't be able to be with us right now, but want to visit us a little bit later. And the webinar topic is related to the support of Reaxys for the specific scientific topics, which is related to food, agricultural, and water. The agenda of the webinar is following. So we will briefly introduce Reaxys, what is inside Reaxys, what is the key idea, how it can help us, and also we will cover the very valuable topics like how to access Reaxys via EKB website, where you can get more materials about Reaxys, some user guides, trainings, videos, etc., etc., etc. At the second part of the agenda, we will talk about general search functionalities from Reaxys. We will cover several of them, like quick search, query builder, how to work with history filters, how to work with export, how to work with the synthesis planner of different molecules. And after that, we will focus on specific use cases. And these specific use cases and workflows was developed for the first time. It's presented for the first time, especially for Egyptian audience. And they position to address agriculture issues and topics. So the first use case would be addressed to the plant research, how to find and get drought-resistant agent. But this is a general approach. It can give you insights about different compounds with desired valuable properties. So insecticides, pesticides, herbicides, veterinary drugs, or some compounds for fishery could be also there. The second use case would be we can call it workflow, would be even more scientific, because it would explain how Reaxys can help you to understand the mechanism of action of the compound which we previously found, and how leverage scientific big data to get insights. Also, it will guide you how to get another molecules with the same properties, and also if they are safe for humans. And one of the final use cases would be focused on the Reaxys support for the water treatment research, for example, demulsifying agents, salting technologies. And during these use cases, we will also cover in some topics related to food research, and we plan to finalize with the section about questions. And from the beginning, let's start from the small session from my colleague Khalid, who will show us how one can access Reaxys and other biomedical database Embase using the EKB website. So Khalid, are you ready?
So basically, as mentioned a bit earlier, Reaxys is available via the EKB portal. To gain access to Reaxys, what you will need to do is to open ekb.eg. That is for the Egyptian Knowledge Bank. And what you will need to do is to register if you haven't created an account. To register, there are 4 main portals available on EKB. These are scientific research and higher education, basic education, readers and kids. A bit of a difference, the ones that would be most pertinent to our users here are either the readers or the scientific research and higher education. Reader is the default account. Any Egyptian citizen with a national ID can create an account using his national ID number on the readers portal, but researchers get more exclusive features and access using the scientific research and higher education portal. So the scientific research and higher education portal is actually split into two. So there is this one for the actual researchers from universities and research centers, so the staff members. And to enter this one, you would need to create the account either by being connected to via from your university IP range or from your research center IP range that is connected to the network provided and the internet connection provided to you by your university or research center. Alternatively, you can also create a researcher account if you have an institutional email domain. So these are the ones that end with edu.eg, sci.eg, .gov.eg, and .plp.eg. So if you have been connected to ekb.eg, if your internet connection goes through your institution, then you will not see the screen and you will be taken to the next step directly. If you have an institutional email, then you can create a researcher account directly using your institutional email. So usually it would end with edu.eg, sci.eg, or .gov.eg. And you would need to click here to go to the registration page. So here I would have to insert in my detail, first name, last name, email, and to confirm email. And I will have to put in my mobile number and national ID. One thing that you would need to notice is that each citizen can only create one account on ekb.eg. If you have had created any account before as a reader, for example, you can upgrade it to being a researcher at any time you feel, if you have met the conditions of having access to an institutional email or institutional IP internet connection. Alternatively, if I go back a little bit, I can also create a researcher account for university students. And because of the lockdown, there are not much restrictions imposed currently on creating an account on the university students portal. So it is an alternative way that you could use for now if you're having an issue with this. If I put in my details and I click on next, I'll be taken to a next screen where I will be asked to put in my professional affiliation details. So just to go over this again with how the rest of the registration would look. So if I'm registering, so I'm selecting scientific research and higher education. I'm selecting either university research center staff members or university student. If I'm connected to the IP and I select a research center member, then I'll be taken to the next step, or for university students, it should be easier. The next step to enter in your personal details. Next, you would have to insert your professional affiliation, whether you are a student or you are a researcher, and clicking on next should take you to ekb.eg. If you have already had an account, you could just sign in directly. Once you've registered or signed into ekb.eg, this would be your landing page. The background can change from time to time. They're using different scientific photos. So, and once you've started on ekb.eg, that's the landing page. There is a search engine that will run your search query along all the databases on ekb. Very powerful tool if you're looking for something really specific. But to be able to use the full capacities of the solutions that you have, I will go to sources, as you can see here, and I would select all sources. And then I would scroll down through the different publishers and providers. So all Elsevier solutions are available on Elsevier. There are few exceptions, including the limited access solutions like Embase and Reaxys. Also, SciVal has a different portal as well. If I go over to Reaxys here and I click on it, so I can see here description of what is Reaxys, and then if I click on this icon here, it would take me to Reaxys solution at the end. So that's a little bit of a quick introduction of how you can actually access Reaxys on EKB. I'll be stopping here, and I'll be laying back again to handing the mic over to my colleague, Dr. Andre, who will take you through Reaxys itself and show how to follow on with the next steps. Please, if you have any questions, please direct them to the Q&A button you can see on your Zoom screen, and we'll be happy to answer in the questions that you have.
And also, just before we continue, first of all, thank you, Khalid, for the introduction how to access Reaxys. And just before we continue, I would like to explain the information how you can get additional materials about Reaxys, where you can get the information about workflows, some guidelines, additional information about Reaxys, and your certificate. To get all of this, you need to go to this website, www.researchacademy.com workshops. The website will ask you to enter the code, and you need to use exactly this code, YPMWGK. And after that, you will go to this page where you can download additional information about Reaxys. You will find several valuable links, including links to the videos about Reaxys and how to use it, and you can get your certificate. Also, I want to highlight that this webinar is a part of another 5 webinars, which will happen very soon. The first is the webinar which we are doing right now related to food, agricultural, and water treatment technologies. The webinar tomorrow would be more medical. It would be about high quality systematic reviews, clinical trials, innovative treatment, and improvement of decision-making in clinical practice with Embase. The next one would be research and synthesis of novel and generic drugs, including the drugs against COVID, hepatitis, HIV, and other disorders. And it will talk about using both product Reaxys and Embase. The next one would be focused on the research topics related to energy and environment. I will do my best to explain the key ideas of green chemistry, of different environment aspects of energy projects, and how big scientific data can help and increase efficiency in this research. And the 5th webinar, last but not least, would be about writing high quality systematic reviews, clinical trials, innovative treatments, and improvement of decision making with Embase. The schedule of the webinar and some additional information, including links to the EKB website for both products, you can find from the Reaxys landing page, this one, and Embase landing page. So, colleagues, just one comment. The 3rd webinar about drug development would be really applicable for the veterinary and fishery research, and I hope you will find something interesting in this webinar. So let's go to Reaxys. And once we start to talk about Reaxys, we need to know that inside of the Reaxys, there is several databases. So it's not just Word. There is technically several databases, and one of the databases is the database of bibliographic records, which cover about 16,000 journals and conferences, and in addition to that, 7 key patent organizations. Another database is the database of substances, chemical substances, organic, inorganic, metallo-organic, big molecules, and it also covers more than 500 million of experimental properties. And we have separate database with chemical reactions, single step, multi-step, and all of them with detailed condition, solvent, yield, catalyst, etc. And also, I would like to highlight that The EKB access is supported with the access to Reaxys medicinal chemistry, which is often called like RMC, to talk shorter. This is a specific database of bioactivity. There is 37 million of experimental data points of bioactivity, and also there is a lot of different targets. And it's really important information, and it's very valuable information because these targets belong to different species. And this is like an idea how it can be helpful, for example, for agricultural research, because these species cover, for example, plants, cattle, fish, etc., etc., etc. So you can find bioactive molecules not only for human, but also for agricultural animals and plants. And how it works and what is the value. The value of accepted data is really very big, and in Reaxys it's not only exists somewhere, but also it's very well structured. So for example, this is the record only for the one substance cetan. And we have more than 2,000 experimental properties for this cetan available just from one web page. And all of this information is collected from 1,600, more than 1,600 articles and patents, and all of this in one page. So just imagine how many time you need to spend if you're working with this compound without Reaxys to collect all available information. During my presentation, at the bottom, often you will see these red words. It is the link to the video guide, how to search physicochemical properties using the Reaxys. And all of these links would be available in the presentation, which is available on the Research Academy website. So I encourage you to download the presentation and get all of these links and all of these videos. In addition to the data, as you see, it is very well structured and very well explained. So it's not only the accepted number, but also Reaxys covers the condition how this number was get. So for example, if you talk about solubility, it's important to know not only the number in gram per liter, but also the temperature and solvent. And all of this is in Reaxys. In this slide, you see a lot of different types of searchable fields which Reaxys cover. In short words, Reaxys have 130 subject areas of different properties. So it's physical chemical properties, spectroscopy properties. So you can make analysis of any valuable compound. It's bioactivity properties like biological effect. It's magnetic properties, electrochemical properties. It's information which is ecological, like oxygen demand, stability in soil, biodegradation, bioaccumulation, exposure assessment. And also there is a lot of, and I really very like it because I haven't found any other database with this. It's information how this or that substance is used by humans. What make difference with Reaxys is, especially Reaxys medicinal chemistry, is taxonomies implemented into the database. With use cases, I will try to explain you about the value, but the key idea is that you need not only the database with the data, you need some solution which make this data discoverable for you. And the taxonomy is exactly the way how you can leverage different types of data, and also taxonomy can help you to generate very interesting ideas based on analogy. On this slide, I collected all searchable fields which are supported with different taxonomies. And to understand that it's with taxonomy, you can see with this icon. So there is 1, 2, 3, 4, 5, 6, 7, 8 different searchable fields with taxonomies. And for the agricultural purpose, we mainly will focus on biological species and on the target name. So it's protein, some protein. So in short words, what makes Reaxys different comparing to other databases? The Reaxys aims to deliver immediate access to the information, but not just the list of reference. What does it mean? So we can compare Reaxys with other database. The other database can find you bioactivity and properties in literature, but doesn't contain the data by itself. So it's how the paper looks, and it's how you can see this data in database. So it's only links to the reference and you see that something is available. But with Reaxys and with Reaxys medicinal chemistry, what you can do, you can find this paper as well. So you can find this paper with detailed substance mentioned there, with targets mentioned there, with different index terms. But in addition to that, you can get access from the information mentioned in the Reaxys, access to the data, which is well explained and contain a lot of details. So to understand why it's important, let's look on these three scientific questions. What is the bioactivity of the substance in the paper? What is the all tested inhibitors of particular target group? And what are all HIV antiviral agents? So to answer the first question, it's enough to read one paper. For example, it contains about 4 substances. The usual cost per paper is $40, and you need just half an hour to do all of this. To answer second question, let's assume that we need about 5-6 papers. It's about 40 substances, and you can do it with 3 hours. But to answer something more complicated question, to make helicopter view on landscape of the research, you need to analyze thousands of publications. This is more than thousands or 10,000s of different substances, and you need to spend huge amount of time, for example, half of the year, just to read and analyze the information from papers. So what's the difference of Reaxys and what is the value of Reaxys comparing to other solutions? Using the other solutions, they give you only the list of references, and you need to get these references, you need to read these references and compare. And only after that you can get the answer on your question. While Reaxys deliver the answer to you immediately. And that's why Reaxys increase your efficiency and effectiveness of your research and help to generate new insights. This is also one interesting slide because often there is misunderstanding and misconception that Reaxys is mainly applicable for the chemistry. But with this webinar, with other webinars, I will do my best to explain how the Reaxys can cover even another scientific topics. For example, material science, drug development, energy like oil and gas downstream, for example, surfactants, plasticizer, or some chemical processes in oil and gas, energy and water treatment, while energy somehow is overlapping with oil and gas, but also energy is solar cells, energy storages, water treatment topic is different chemical processes related to water treatment, environment and safety, and agricultural research. So all of this, and for sure drug development, as was mentioned, is different research use cases which where Reaxys can contribute. And I wouldn't be surprised if by yourself after the webinar you can imagine even more use cases where can Reaxys add value. So let's go to the online training, and let's talk about Reaxys and see Reaxys. This is the main screen of the Reaxys, and on the main screen you see automatically it's switched to the quick search mode. In the quick search mode you can type something or you can draw the chemical structure. So again, you see some links to video how to use this search. When you type there something or draw the structure, you can click the button hide, find, and you will see this intermediate page. Why it's happened? As we already discussed, inside of the Reaxys there is several databases, and quick search is a fast tool which help you to quickly search in all three databases. So for example, if you are interested in preparation of cisplatin, you can type it, and Reaxys will recognize your search intention and find that you may be interested in chemical reactions related to cisplatin, and it will search in the reaction database, but also you may be interested in document database. That's why Reaxys will search in document database for the word preparation and cisplatin, and these words separately. Why it's valuable? Because often when you are doing quick search, you can misspell something. And when you do it, you will see that, for example, if you type cisplatin incorrectly, you will see 0 document for the incorrect word. But this will guide you where you need to make changes. What is another interesting point, and I want to show you how it works in the Reaxys. So here is the Reaxys. Let's try to find something. So we start to type, and Reaxys recognize that we might be interested in some chemical molecule, and he advises us what it could be. Let's move out from standard aspirin. Let's choose something else, and let's click here, find. So what we see here, we see 9 reactions as discussed, but also we see documents. And now I will open you some untrivial secrets which people who are not visiting webinars wouldn't find by themselves, because it's intuitive, but usually people miss it. And what I'm talking with you is this small button, Edit in Query Builder. If you click it, you will go to the query builder and you can see how exactly Reaxys made the search for you. And if you like it, it's good. But if you don't like it, you even can make some correction on it. So what we are interested in? We are interested in preparation of some particular compound. But at the same time, the wording for this idea can be expressed differently. And Reaxys support us with different synonyms. So for example, you see there is a lot of synonyms: formation, make, making, manufacturing, preparation, synthesis, etc. So Reaxys automatically search by using all these combination and synonyms of the word preparation. But also, as you see, Reaxys search for different chemical names for the substance of our interest. It's add different names, and with this we can get as much comprehensive as possible library of the documents related to our search topic. Another interesting tool which we also need to cover is this drawing tool. So we can click here and we can draw the compound of our interest. So some researchers like to use Marvin.js, someone like to use ChemDraw. It's fully up to you. You can choose which of them you like. My preference is Marvin.js, and with this you can draw the compound of your interest. So for example, you can take some frames from here, for example, ring. Here you can add different bonds. So it can be single bond, double bond, triple bond, any bond, coordination bond, or I like this tool, it's position variation bond. So for example, you can set that you don't care where exactly this bond allocated on which of these atoms. Right now, it have not a big sense, but if we just add one carbon, it's become 3 different compounds. So it's one of the tricks. Here it is, position variation bond, this one. Also, what you can do is to use Reaxys smart groups. So you can type several groups and put them into the account. Also, what I advise you is to don't forget to click here, help. So from here you can get to Reaxys support center, and there is a lot of valuable materials. One of them is focused on these Reaxys generic groups. So you can get more details about it. What is the idea? If you don't care, for example, which particular alkyl is this, you can click here, any alkyl, and it will leave you any alkyl compound. Also, there is very nice periodic table, so you can use any atom. And also some of them are here. So for example, if you would like to add chlorine here, you can search. What else need to be mentioned is these options. So you can search the structure as it's drawing right now. You can search for any derivatives of this structure by clicking here as substructure. So the system will find all molecules where this is the original part with some additions. And also to generate some insights you can use for similar compounds with different layers of similarity. Let's click it like here. After drawing, we need to click transfer to query. And now we can click find. So Reaxys give us several compounds. Also, it search in the biomedical database and says that he don't know any targets which interact with these compounds, and it automatically search for similar compounds in PubChem. And you also can see several reactions related to the structure for which we are searching. So let's go there, and here is the tables of the reactions and compounds which we mentioned. These compounds doesn't look really very well investigated. That's why we have a few data about it. But anyway, even for this one, you can access to physical properties. There is chromatography data, crystal property data, some spectral data. And also here, you can get the preparation from this compound and all reaction of this compound. Just clicking here, reactions. So here it is. It's the chemical reaction of this compound, one of them. And another one is the reaction of formation of this compound. You can see the reference, and you can see the yield. You can see the solvent, you can see the catalyst, you can see condition. And also there is a link full text, which will bring you to the website of the publisher who published this paper where this reaction came from. And also there is the link cited 40 times, which will bring you to the Scopus. So you can see who, sorry, who already cited this article. Okay, let's wait a little bit to see how it's reflected in Scopus. Yeah, So you see a lot of compounds, a lot of documents citing the document which we found. And this is Scopus. I think you already aware how to use it, and you know everything about it. So let's come back to the presentation. We cover this, and there is a video how to search reactions. What else we need to cover is come back to the history. So we did several searches, and once you did the searches, you can click here and you will see the history of your searches. Reactions, substances, documents. You can edit them in Query Builder, you can save them, and you even can create alert for them. So let's come back here. What else is quite interesting? Here you see the filters, and the filter view depends of what is in which database you have this view. So for example, for document view, you will see this type of filters. For substance view, it would be another one. Let's click here, and you see the substance filters looks quite different. And also you can go to the reaction, and reaction one also looks quite different. So in reaction, for example, you can see the catalysts, you can see the solvent, you even can select the catalyst class, which is supported by very good taxonomy from the Reaxys. So for example, you're interested in catalyst with active center based on zinc. Also, you can choose different solvents, and this is also might be of interest of organic chemists and of environment researchers, because with this you can search, for example, so filter only, for example, to green solvents, like just click here green, and you see we go from 3,000 reaction to 600 green reaction. And all these reactions have reference, have yield, have details, and also here it is experimental procedure. This is the paragraph which is taken from the original document, patent or journal, which explain you how you can do this reaction. And also, as you see, the same reaction can contain several links. Why this happened? Because, for example, you see in this paper, the reaction was done with sodium hydroxide plus 20 for 16 hours, and the yield was 100%. But in this case, it was used 3-methylamine, but also in tetrahydrofuran, and for shorter time with lower yield. So you can easily assess what would be the best condition to make your reaction, and some of them supported with detailed experimental procedure. What else we need to mention is the synthesis planner. So for example, you found some substance of your interest and would like to know about the ways of how get them. One of the options that to get these compounds is with Reaxys is to check commercial availability of the compound by clicking this icon. So you will see several suppliers, and you can click and you will get to the website of this supplier. Right now it's Chemolecule, and in the supplier web page you can see details about the molecule, and you can find the price for it. Another way to get this compound is to synthesize it, and not only reaction is presented in the Reaxys, but also we have automated tool which is called synthesis planner. So if you are interested in retrosynthesis of this molecule, you just need to click here, select auto plan, make some options, or just click create a plan, and the system will suggest you several synthetic options. So for you, it's not clear how to get this one. What you can do? You can continue your your plan and create more steps for this molecule. So you see, this one can be synthesized this way, or this way, and all the experimental conditions for each step. This is step number 1. This is step number 2. 2A, 2B is presented on the table. And also at the left, you can choose different synthesis plans, which is prepared separately, independently. So we finished with basic search functionalities, and let's go to the advanced use cases related to agricultural research. First one is, as we discussed, is how to get anti-drop agent, and we will discuss several strategies with you. All of them would be focused on the using query builder, and as you might understand, there are a lot of search capabilities available with the quick search for anyone, but you as a participant of our webinars would be advanced Reaxys users, and you will know how to use query builder to make complicated search. So how you can do it? What is the steps? It's, by the way, it's one of the another point, value point of this webinar, and it present in the presentation. The slides would be presented as you see them, and it's step-by-step guide. So first you need to click query builder. Second, you need to type use here. Third, you need to drag and drop it here. Fourth, you need to expand this list, type something, make search, and you will get the results. You can browse the results, you can find the hit data, and also you can get the link to the original text. So how it looks in the Reaxys. Let's go to the Reaxys. Let's go to the query builder. Let's clean everything, and let's type use. What is this? What is this? I always laugh when I talk about it, because it's, as we talk, as we mentioned, Reaxys have 500 searchable fields, and this is searchable fields to search searchable fields. Isn't it something? But it's very applicable, because it might take some time to find something relevant, but with this one you can easily get it. So we find the field related to the substance application use. We drag and drop it here, and we expand it. There is line related to laboratory use and handling, and also this one is about use pattern, which comes from patent claims and also comes from the articles. So let's search for the word drop in this searchable field. After we did it, we need to click here, substance, and we got 143 substances, which is referred in patents or in articles for the potential use as anti-drop compound. How it looks like. So here it is. You see, for example, aspirin, or this molecule, or this molecule. There is a lot of different data about it, like drug likeness, the information about identification, so substance labels, catalyst investigation, some derivatives. patent-specific data. It's Marcus structure, which can be found in the Reaxys. It's additional information about purification and a lot of bioactivity data, in vitro, in vivo, metabolism, pharmacokinetic toxicity, physical data like melting point, refractive index, density, absorption. And please remember that all of this is searchable information. So you can find it by searching some compounds which have absorption with this partner. You will find aspirin as well. So there is a huge amount of different information, and Reaxys even help you to find the needle, because it's highlight you from all this information only hit data. And you see, if I click here, you see the click data. So aspirin is mentioned in this patent that it's improving anti-drop capabilities in combination of with diethylaminohexanate. Let's go here. For example, this abscisic acid. It's also mentioned that it's increased drop resistance, but right now it's referenced particularly to plants, which might be more relevant for agricultural research. And we have two reference, one patent and two patent, second patent. So you can click full text and you will go to the web page where this patent is explained, or you can click details and see additional information from the Reaxys. You can get abstract, you can get claims, front page, substances mentioned in this patent, and also the link to the full text. So we found 133 compounds, which is referred as drop resistant compounds. And even for this abscisic acid, we have a lot of information about its properties, bioactivity data, physical data. For example, you can see melting point, boiling point, chromatography data, where you can find a lot of links on how to make HPLC, ultra performance liquid chromatography, TLC, LC, etc., even rotary power and other information. So it's workflow number one, to implement use search field from the query builder. What is workflow number two? The workflow number two is to search for some information in the substance effect search field. And what is the difference? What is the difference? Let's see what is the difference. When you use this one, it's any text, any wording from patents and references, but substance effect is the bioactivity effect, which is excerpted from the document. So this one is more detailed, and when excerption is done, it is supported with some synonyms. So this one would be more specific one. If we are interested, we can click here and you see the whole list of different bioactivities. So for example, you might be interested in pesticides. Let's just start typing and you see 90,000 different pesticides. There is information about phototoxicity, photocytotoxic, insecticides. Here it is, different insecticides, repellent, insecticides by itself, herbicide, herbicidal agent, fungicide, different fungicidal agents. So you see there is 124 pages of these different bioactivities, and you can even browse them. So you start to type something and you find the options. So for our use case, we need this one, drought resistance and drought resistant agents. But for your research, you can choose whatever you want. So for example, even something like this. Carcinogenic. Cytotoxicity. Even death cases. So it contains a lot of different types of bioactivities. Transfer again and click search substances. Now we got several substances, but also as a result, you can see the bioactivity heat data, which is much more specific. So from here, you can see the detailed specific information about quantitative results. You see the parameter, you see the species, you see dose in regime, if it's animal model, and even the effect. So from here, you can see that for Arabidopsis thaler ecotype called 0, there is drought resistance, and the px value, which is quantitative amount, which is quite high. But for example, for Williams 82 soybean, the px value is 1, which means 0. It's not active. You see, it's not active. So for different plants, for different plant species, the bioactivity of this compound is different of the abscisic acid. And you can browse it with your experimental task, your experimental queries. So what is there? It's explained on this slide as well. What is the next here? As we discussed, by clicking the cited by, you can go to the Scopus and see who is citing this paper. And in this slide, I collect different seed agents which might be relevant for agricultural research, which I found in the reaction. So for example, you can do the global search and use star seed. Let's see how it looks. So here you can clean everything, and it's one of the Reaxys tricks. In the query builder, in this text search fields, you can use star, which mean anything. So let's find all compounds which end by seed. Or we can even add another star, which will mean that the seeds should be somewhere in the middle of the bioactivity. But let's search for all seed compounds. And let's click here. We got 123,000 of different compounds with bioactivity, different bioactivity. What we can do there? We can filter them to the compounds which with only high bioactivity. And what does it mean? As you know, the bioactivity can be presented in different units. It can be nanomole, micromole, milligram per liter, etc., etc. And these different units makes complicated to compare results which you get from different experiments. What Reaxys do? All of these units converted to unitless parameter, and the logarithm of it taken, and the final unit is called px, which is logarithmic affinity. So now you can easily compare nanomoles with micromoles and see that 7, which is higher in logarithmic scale, it will mean that bioactivity against this target is much higher than this type of bioactivity. So what we can do, we can filter only to the very high bioactivity, for example, higher than 5-6 folds, and focus on only highly bioactive compounds. Again, we see this heat data, and for example, we can see that this complicated molecule is a suicidal agent. Well, it's not very useful for agriculture. You see some toxicity, LD50, and all other different compounds. What I also want you to show is this tool, which is called heat map. You can click here and make the heat map. On the one X, you can choose substance. On the another X, you can choose what several parameters. For example, let's focus on the effect, for example. And here you see different compounds. For example, here, herbicidal agent, herbicide, and all highly active herbicidal agent. You can click here and sort it. And you see, this is exactly the list of high active different herbicides. So for each of them, you can click here, this icon, and go to the substance if you like it. So copy to clipboard, copy to query, or you can click here and see details immediately on the screen. So again, you have reference and you have parameter which was measured. As you see, there is different type of activities. For example, nematocidal, pesticidal, sporocidal, even biocidal, bactericidal, arthropodicidal, and all of this comes from just one search. Originally, it's come from this search. We try to find different seed compounds. So if you find something interesting for you in this table, you can try to put it here in the substance effect, or you can try to find something more relevant for you by browsing different types of substance effect using this icon. And the also very important strategy, which we already covered previously, is to assess how to buy or how to synthesize compound. Click here to get commercial suppliers. Click here to create retrosynthetic plan, or click here to find preparation of the compounds. In the reaction, you can use experimental procedures to understand how to do it technically, which glass use, what's the temperature, if you need mixing or if you don't need mixing, or you can use filters. Also, this is about synthesis planner, and by clicking full text, for example, you can, if it's Elsevier article, you will go to Science Direct and you can get the full text of article. And also Reaxys even give you ability to predict chemical stability of the reaction. how it can be done. So, for example, you are interested in some compound which have one aromatic hydroxyl group and one aliphatic hydroxyl group. How to search it? You can do it easily. This is aromatic part. This is aliphatic part. This one is position variation, meaning that it can be anything. What we are missing here? Right now, we will search only for phenols. But in our big idea, we need to find the compounds where these groups can be in different positions. That's why we might appreciate Reaxys generic groups and these G groups. G groups mean anything. So here is G group like anything, GH, anything or hydrogen, G star, anything or even connecting to the cycle, anything hydrogen or connecting to the cycle, or even polymerics one. But this one would be enough. We can put it here and select substructure. And what we now missing, we need to show the systems that we are interested in the reaction. That's why we need to put the reaction arrow. So now we would be interested in all reaction of the compounds which have one aromatic group and one aliphatic group. And we need to go here, search reaction, and sometimes wait a little bit, because even if Reaxys looks to work very fast, some queries can take some time to search, and very complicated queries, it's really very rarely, but it's happened. So this can take up to even several minutes, like 20, 30 minutes, or even 1 hour while Reaxys doing this search, because some querying can be very, very complicated. So while the search process is going, let's go and analyze what we can get there. Sometimes ago, when I did this search, it bring me 4,300 different reactions from 800 documents, and I use filters to assess what can happen with my compound. Why this is possible? Because Reaxys index the details about chemical reaction, about substances, and add index terms, but when I deal with reaction, it's supported with a lot of interesting indexing terms. So for example, it's not only the catalyst, the solvent, but also Reaxys try to understand the type of the reaction and the class of the reaction. And as you see, where indexers success in it, you can find this information in the filters. So this particular reaction of our interest, what can happen? It can happen the substitution reaction, hydrolysis reaction, CC bond formation, ring closure, cyclization, oxidation, reduction, or cycloaddition or whatever. And what is of our interest, for example, we want to assess is it stable or not. We can first of all go to the reduction reaction and see different conditions for the reduction reaction for our group. Or also we can go to oxidation reactions and compare is it different from reduction one, and what we need to add to stabilize the compound, what we need to add to stabilize our compound. As you see, it's not finished. And let's go further. What else you can do? If you are interested in some particular reaction, so for example, you would like to keep this group, this hydroxyl group, but you want to oxidize only this one, you can use the bond properties, and you can set to the Reaxys that you want to get all the reaction where exactly this bond would be the reaction center. How you can do it? You highlight this bond, you right click on it, click bond properties, and here you select reacting center. Just select here center, and it will mean to the database that the conversion should be done only there. Let's cancel it, and let's see what it means, what I just tell to you. So you can use Ctrl+C, Ctrl+V. Yep. Now let's select double bond here, and let's choose bond properties. This is reaction center. So this bond needs to be converted into this one. Let's transfer it to query, and let's search for the reactions. This one looks a little bit faster than previous. And I want to show you why it's important to take this into account. What would be the result? As a result, you will see a lot of reactions which should match your expectations. So all the structure should be kept, and the part of your query would be highlighted with blue, and you might see that hydroxyl group converted to keto group. Okay, let's not spend the time and come back to it later. What is another use case? Another use case, how to search information relevant to agricultural research. So for example, for the kettles, if you want to increase their properties, specific properties, what you can do is you can do the text search in the quick search. So you can just type the desired effect as it's written in articles, like for example, muscle growth. Find all articles related to muscle growth, and here you will get about 6,000 documents, which cover 1,800 different substances mentioned in these documents. You need to click here, and you will go to the list of these substances, and some substances where there is valuable information related to this reference. So the reference in title, in abstract, somewhere have wording muscle growth. This will appear in the heat data. So even what you see, even if this use case is energy increasal as nutritional composition, so it do not contain muscle growth, but abstract of this patent or some text in this patent contain muscle growth, that's why it's appear here. I hope you got the idea. And this search still going. So I assume you need to believe me, because I won't to show you the use case about muscle growth, how it works. Via type muscle growth, we found the documents related to muscle growth. Here it is, a lot of documents. We can read them separately. Here is abstract, index terms, a link to the full text, but also some of them have index substance, for example, like this one. And here it is. This is substance mentioned in this paper. And we can go to the list of these substances by clicking here. So you see the databases of substances, of documents, of reactions are really very easily interconnected with each other. And some compounds have used documents related to muscle growth. And for example, the glucose, it will appear as a heat data. And I think it's clear that the glucose improve endurance, nutrition drinks, sport drinks, etc., 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 and support the muscle growth. So you can use this workflow as well. What is another use case? Another use case is to find insights about mechanism of action. So how it can be done? As you remember, we already do this substance effect search, something like DROF effect. And the idea is when you browsing this data in the bioactivity heat data, you can see not only the effect and dose by itself, but also you can see the target relevant to this effect. So how it looks like. As you might see right now, my session is expired, and if you would like to have prolonged session, you need to click register and put your own login and password, register your own login and password. So let's search for the substance effect like this one. And you see in the efficacy, you see the target responsible for anti-DROF effect. Or if you choose any other effect, it will be any other target. So what you can do? First of all, you can browse all this information, and you see that this is different types of abscisic acid receptors from Arabidopsis, from soybean, from other compounds. Or also you can make the collection of different targets. For example, from here, again, it's mainly the same receptors. And what you can do is you can find all molecules affecting these targets. If you would like to choose, you can click here and you will see only this target, but you can make the search for all targets like this one. And you can do it with the following workflow. Type here target, target name, and it contains taxonomy. So by clicking here, you see that targets connected to different species, different functions, etc., etc., etc. So what we found is that all of them are connected to the abscisic acid receptors, and we can select all of them. For example, this one. you see the system automatically connect all targets connected to abscisic. We can browse the list here. We can remove if we found something irrelevant for us. For example, I don't like this one, and this one, or this one. After that, just click transfer, and we have this search query. Now, let's select all substances which active against different abscisic acid receptors. As you see, previously by anti-drop activity, we found only 15 substances. By this workflow, via the targets, we increase it to 420 different substances. So we generate additional insights. This is abscisic acid. The receptor, and as you see, for example, for this compound, the effect is not indexed, probably because it was not indexed in the patent, because the author of the patent maybe would like to hide this information, but at least they put the information about the target and about the compound which affect this target. So this is the workflow to increase the productivity of your search. What is another workflow which can help us to generate insights? Another workflow is to find all compounds which is similar to abscisic acid. How to find them? Click here, view options, and click here, find similar. And different types of similarity, like just position stereoisomers, near, which include structure containing same ring, same change. So different types of similarity, you can see that the funnel is growing, and here is only 17, the 100 for the medium similarities, more than 300, etc., etc., etc. So this how you can generate some insights. And also, not only similar compound, but also you can copy abscisic acid to query and find all derivatives of this compound. What is the idea? You can assess the bioactivity of this chemophore. So we found 500 compound, which is derivatives of abscisic acid. You see, it's even some mixtures, and you can click heat map, select targets, and see the comprehensive bioactivity of all derivatives of this compound. So you see additional information that, for example, it interact with this target, protein phosphatase. It's interact with choline esterase, with carbonic anhydrase, etc., etc., etc. And by assessing these targets and by assessing the bioactivity to them, you can predict the bioactivity of the compound of your interest. In the presentation slides, all of this is explained and mentioned. What about food? What about food chemistry? Let's represent it, for example, on analyzing this article, which assess pesticides and the potential outcomes on the human health. So in these articles, we can see that they index some substances, including this one, and this one is diazinon. And in Reaxys, in other data, you can find a lot of ecological and safety information, like exposure assessment, concentration in the environment, transport and distribution, bioaccumulation, biodegradation, abiotic degradation, hydrolysis, photolysis, stability in soil, etc. And here you see how it looks like. So, for example, biodegradation, that it's quite stable. And from the fact that it's quite stable, you can expect that it can be detected in the food. So you might leverage spectral data to find some analytical techniques to identify these compounds. For example, NMR or mass spectrometry, or use chromatography to analyze this compound. But also you can assess toxicity and safety of this molecule here in bioactivity, in the toxicity and safety. And you will see that it's quite toxic, even for very small dosage, but you need to assess the species. So for example, this one is definitely not a mammalian zebrafish. What about water treatment? With the water treatment example, I want to highlight the use case, how Reaxys can help you to find information and analyze literature. So why it's important? Because Reaxys index not only substance and reaction, but it index full text of articles and patents, and it add the index terms related to engineering from Compendex, to biomedicine from M3, and related to chemistry from Reaxys index terms. So it's the comprehensive overview of the articles from several viewpoints, from the viewpoint of engineering, from the viewpoint of biomedicine, and from the viewpoint of chemistry. And how you can leverage it. With Reaxys, you can analyze these chemical index terms. Let's see on live example. So we are making literature search for the water treatment, or you can do the more specific search related to your research, like demulsifying agent, desalting technology, water purification, or whatever. I make quite general water treatment, and we find a very big amount of different documents, 150,000 of documents, and it's clear that no one can read all of them. But it's very big topic, and we would like to assess this topic for some directions. How Reaxys can help with this? So one of the options is to find all index terms from Reaxys 3 here in the filter. So all 150,000 papers got the index terms, and they analyzed, and you see statistics of appearing of some concepts. Reaction, kinetic, adsorption, which is quite relevant for the water treatment, for example, for the purification. Wastewater, which also quite relevant. Oxidation, separation, and for example, you can see from here that oxidation is and separation is used quite often, and the occurrence is more or less similar. Also is some organic related to organic compounds, or for example, you can find and analyze some processes. So for example, the word chemisorption is quite often used for the water treatment, or coagulation, or any other. Yeah, here it is, coagulating, or for example, coagulation. So if you are developing technologies related to coagulation, or considering coagulation as an important step, you can benefit from this filter. And in couple of clicks, we got insights, what is done related to water treatment. And also we focus on coagulating agents. There is 3,000 of documents related to it. Again, you can go to the substances, and all of these substances would be related to, first of all, water treatment, but also to the coagulating agents. Also, you can use this type of filters, Reaxys index tree, and it's also quite interesting. Why? Because all index terms which we referring to are connected to the taxonomical tree. So coming to the coagulation, you might be interested what kind of physicochemical properties might be relevant to coagulating agents. And you can open it and see that mainly it's transport phenomena, but also electrochemical properties. It's clear that they are very important for the good coagulating agent to be stable. It's some chemical properties, mechanical properties, and you can even go down to find something specific or analyze the topic. So it's the properties of compounds. This is chemical reactions, which often used. For example, you can see here reduction reactions. And also there is a physicochemical analysis method, which explain different analytical techniques which used in water treatment or in including coagulating agents. So more often it's separation methods, and because it's related to chromatography. Also the spectroscopy used quite often, and as you see, the most often the infrared spectroscopy is used, much more often than NMR, for example. So if you are interested in any articles related to analytical methods, you can click this, select this big one. But also what you can do is to select specific topic, for example, microscopy, even including some subtypes of microscopy, and use it as a filter. So with Reaxys, you can analyze and browse literature from the viewpoint of chemistry using the different taxonomies, chemical taxonomies. We have discussed all of this. And again, for example, water demulsification. One approach is to use the analysis of the literature. So you can type water demulsification, found some documents related to this, but also you can use filters, and you see that from the Reaxys index terms, the dehydrogenation is often used with water demulsification like a chemical reaction, or for example, that it's often use different separation methods, surface active agents, and it's clear that surface active agents are really relevant to water demulsification. But also you can find the substances which is used in demulsification. So with the use field, which we already covered today. Because there is a lot of different spellings with the same meaning, I prefer to use star and find all substances, like 55 substances. And you see that Reaxys cover not only organic and inorganic compounds, but also polymers and even some mixtures of polymers. So polyethylene oxide is used, lubricating oil demulsifier, for example, or this another oxide of polymer demulsifier. The same approach can be used, for example, for desalting. So you see different compounds used for desalting. Regarding to water treatment, it's also need to mention the analytical chemistry, and Reaxys can support with this as well. So for example, if you are interested in chromatography of different phenols, which is quite well known impurity of water, you can do the quick search like this, HPLC of phenols. So let's click search. And for some substance classes, Reaxys recognize it, like for phenols. He will automatically search for all substances which are derivatives of phenol and have HPLC properties, but for someone, you need to justify it one by one. And honestly saying, if you talk about, as a result, 137 substances, I don't want to analyze it. I prefer to specify some phenols and ask Reaxys to search. For example, something simple like this one. And also I can do like this, so HPLC. And the system will recognize it as you're interested in property, HPLC, and all substructures of substance which you draw. And you see there is cresol, HPLC chromatographic data, and for this cresol we have something as well. What else we have not covered? Here it is. It's quite interesting, for example, when we deal with water treatment, also to talk about absorption of heavy metals and how you can do this search in the Reaxys. To search substances, we have structure editor, which we already covered. Also, we have Brutto formula search or CAS number. And if you click here, you can request this very smart periodic table. Here you see even some big classes like alkali metals, lanthanoids, actinoids, transition metals. You can put some class or you can put specific metal, for example, plumbum. You need to be careful because if you click here, use this formula and choose substances, it would be search exactly this formula. And if you're interested in different derivatives of plumbum, organic or inorganic, you need to use star. And let's search for absorption. Yeah, here it is, adsorption. Let's search for any data about adsorption of plumbum derivatives. So we see lead by itself, which can be absorbed on different partners from this solvent under this temperature. Here is the reference. And also we see different lead derivatives. For example, lead ions can be absorbed by some specific halides. And you see these halides. In this slide of the presentation, I make small summary about different approach to explain some ideas and limitations. So one of them, which we talk about today, was use the implementation of use search field from the query builder. You can use here any text combination with wildcards, logical and proximity operator. So it's limited only by your scientific imagination. For example, crop protection, plant protection, meat, milk production, milk, fat, or names of some cattle or plant disease or fish disease, names of the food component, corrosion inhibitor, specific agent like demulsifying. You can leverage the substance effect search field in query builder, and it cover around 2,000 different specific bioactivities. You can select from the list or try to type it, like phagocytic, vasodilator, antioxidant, etc. You can search by specific biological target, again using query builder, and you can search both specific name or even target taxonomy. Also, it's important to show you that we have taxonomy of species, not only of targets. Here it is, biological species. So for example, let's search for Arabidopsis. And it's quite good example of the taxonomy. You see that Arabidopsis is a subtype of Brassicaceae, which is subtype of Brassicastle, which goes to rosid. And for example, if for your research, you would be enough to get all the information about all rosids, you can click here and get everything about all rosids. Or you can even go to some subtype of Arabidopsis. If you select all rosids, you can find 400 different targets from different plants, but also if you select something specific, you will find much less targets. So for example, this one. Only 27, not 400, but which all of them more specific. And when you find these targets, you can click here, some substance, and got substance active against these targets. Also, with target taxonomy, you can use more or less the same. So you can select, for example, all targets from fish. Or you see some targets related to toxin or storage protein. So you see a lot of targets related to zebrafish. And with this, you will find substance bioactive for fishes, 1,300 different substances. Here it is. It tested on zebrafish. So you can search by target, you can search by substance, or even by, you can use name of the substance, you can use structure, you can use a substructure, you can use similar targets, you can use broad to formula from the query builder. You can draw the structure from both quick search and query builder, and you can discover some scientific topic from the quick search. It's the easiest way, and from this scientific topic, you can go to the substance related to the scientific topics. So right now we cover almost all the questions, almost all presentation materials, and now we can go to the.
Thank you for the presentation, Andre.